In this video, we're going to focus on finding the area using the limit definition. So let's say if we have the function x cubed, and we want to find the area of the shaded region between the x-axis and the curve over the closed interval from 0 to 8. So let's draw a picture. So x cubed on the right side looks like this. And so from 0 to 8, we want to find the area of the shaded region. How can we do so using the limit definition? Well, you need to know the formula. To calculate the area, it's equal to the limit as n approaches infinity of the sum of all of the rectangles starting from 1 to n of f of x sub I times delta x. Delta x represents the width of the rectangle, and f of x sub I is the height of the rectangle. So as n becomes very large, we're going to use an infinite number of rectangles to approximate the area under the curve. And we're going to add the area of each rectangle. We're going to sum it up, and that's going to give us the area under the curve, which is equal to the definite integral of the function from a to b. So what is x sub I, and how can we find it? So if you're using the right endpoints, x sub I is equal to a plus delta x times I. If you're using the left endpoints, x sub I is equal to a plus delta x times I minus 1. So let me illustrate the right endpoints, because you can use either one to get the same answer, but the right endpoints is a lot easier than the left ones. So let's make a number line, and let's go from 0 to 8. And for this particular illustration, we're going to say that n is 4, but for the actual problem, n goes to infinity. So this applies only for this illustration. So if n is 4, what is delta x? Delta x is b minus a divided by n. So keep in mind, a is the beginning of the interval, b is the end. So it's always from a to b. Now b is equal to 8. A is 0, and then n is 4 for this example. So 8 divided by 4 is 2. So the width of each subinterval is equal to 2. And so that's the value of delta x. So now let's use the formula. Well, first let me get rid of some stuff. So let's use this formula. X sub I is equal to a plus delta x times I. Now for this example, we said that n is 4. And so we're going to have x1, x2, x3, and x4 as you start from 1 and end at 4. So using the right endpoints, we need to choose 4 of the 5 points listed on the number line. And so we're going to use the 4 points on the right side, 2, 4, 6, 8. Now when I is 1, the x value is 2, so we could say x sub 1 is 2, and x sub 2 is 4. Let me use a different color to distinguish it from the stuff above. So this is x sub 1, x sub 2, x sub 3 is 6, and x sub 4 is 8. So if you want to calculate the value of x sub 1 using this formula for the right endpoints, we start with a. So keep in mind a is 0. Delta x, we said it was 8 over 4, which is 2. and I is whatever the subscript is, so I is 1, and this is equal to 2. So x sub 1 is indeed 2. Now if we want to calculate x sub 2, it's going to be 0 plus 2 times 2, which is 4. And if we wish to calculate x sub 4, 0 plus 2, I is 4. So that's going to have a value of 8. So x sub I, it tells us the value of x at some point along the number line. So now let's go ahead and work on this problem. So we said before that the area is the limit as n approaches infinity, and we're going to sum up the area of each rectangle from 1 to n, where n goes to infinity, f of x sub I times delta x over the interval 0 to 8, where f of x is x cubed. So let's calculate delta x. Let me do it on the right side. So delta x is going to be b minus a, so that's 8 minus 0 divided by n. But in this case, we don't have a specific n value because it goes to infinity. So we're going to leave delta x as 8 over n. The next thing we need to determine is x sub I using the right endpoints. So it's a plus delta x times I. And we can see that a is equal to 0. Delta x is this thing over here. It's 8 over n times I. And so this is x sub I. So let's replace x sub I and delta x in that expression. So the area is going to be the limit as n approaches infinity, and then it's going to be f of 8I over n times delta x, which is 8 divided by n. Now let's evaluate the function when x is 8I over n. So we need to replace x with that. So we need to rewrite what we have. That's the limit as n approaches infinity. And don't forget the sigma notation. And so this is going to be 8I divided by n raised to the third power times 8 over n. Now 8 to the third power, so that's 8 times 8 times 8. That's 512, and then times another 8, that's going to be 4,096. This problem involves a lot of writing. So we have 4,096, and then we have I to the third power, and then this is going to be n raised to the third power times another n, so that's n to the fourth power. Now we need to apply the summation formula. And there's another video I created entitled Summation Formulas in Sigma Notation Calculus. You could search it on YouTube. If you have trouble finding it, just type in Organic Chemistry Tutor as well in the search box. It should come up. Or you could find it in my new calculus video playlist. But you need to know the summation formulas for a constant, for I squared, and I cubed. So we're going to use the one for I cubed. But let's rearrange this expression. So right now we have the limit as n approaches infinity, 4,096 over n to the fourth, and then the summation formula for I to the third. Now, don't apply the limit. Make sure you apply the summation formula first before you apply the limit. The summation formula that corresponds to this, that is I to the third, going from I equal 1 to n, it's n squared times n plus 1 squared divided by 4. So let's simplify. First, we could divide 4,096 divided by 4. 4,000 divided by 4 is 1,000. And 96 divided by 4 is 24. So we're going to have 1,024. And then n squared divided by n to the fourth, that's 1 over n squared. So we're going to have an n squared on the bottom, and on top we're left over with n plus 1 squared. So at this point, it's all math. So I'm going to move the constant to the front, because the limit will not affect it. Now I'm going to FOIL n plus 1. So n plus 1 times n plus 1, when you FOIL it, it's going to be n squared plus 2n plus 1 divided by n squared. Now I'm going to multiply the top and the bottom by 1 over n squared. And so we're going to get this. So it's going to be 1 plus 2 over n plus 1 over n squared divided by 1. Now, let's say if you have the limit as x approaches infinity for 1 over x. 1 over infinity is 0. Or, if you have this for 1 over x squared, 1 over infinity squared is 0. So anytime you have a fixed number divided by a very, very large number, you're going to get a small number. And so this is going to be 1024. And now applying the limit expression, 2 over n becomes 0. So this is going to be 1 plus 0. 1 over n squared will also become 0, divided by 1. So this is 1024 times 1. So the area is 1024. This is the answer. Now let's confirm it by calculating the value of the definite integral of the function from a to b. The area is equal to the definite integral of f of x dx from a to b. So a is 0, b is 8, and the function is x cubed. The antiderivative of x cubed is x to the fourth over 4. And then we're going to evaluate it from 0 to 8. So this is going to be 8 to the fourth over 4 minus 0. Now 8 to the fourth, we know this, it's 4096. And we know that 4096 divided by 4 is 1024. So evaluating the definite integral is a lot faster, but sometimes you may get a free response problem and you have to do so using the limit definition. Nevertheless, you can confirm if you have the right answer by finding the value of the definite integral.